DevOps, slow builds cost time, and broken images cost trust. So today we'll build Docker images that are actually production ready, fast to rebuild, layered for caching, and clean enough for CI/CD. Hey, I'm Natalia. I've been in engineering for around 20 years now, across freelancing, startups, and enterprise projects. My goal here is to help you master DevOps one essential skill at a time. So let's make your Docker skills unbreakable. We'll start simple and build it up, so you see how Docker actually thinks during a build. Let's jump in and write our first Dockerfile, the one that will turn our code into a working image. Here's the one we'll start with. It's a simple full-stack app, TypeScript backend and React frontend. You can grab the repo from the link below if you'd like to follow along. The idea is straightforward, one image where the backend serves the build frontend. A Dockerfile is basically a recipe, a set of instructions that tells Docker how to build an image. We start from a Node.js image, that's our foundation. Then we set the working directory and copy our project files inside. These 3 lines define where and what we are building. Next, we build the frontend and backend, installing dependencies and creating production builds. Then we copy the build frontend into the backend's public folder. At the end of the day, we want one image that serves everything. And finally, we switch to a safer user, document the port, and set the start command, so the container just runs. Now let's build the image from this Dockerfile and give it a quick test. Let's start a container from that image. And there it is, our full-stack app running from the image we just built. It works. But there is a lot we can improve. But first, let's recap. So, this image works, but it isn't very efficient. Every small change triggers a full rebuild, and that's a classic Docker problem most teams run into. Let me show you why that happens and how to fix it so your builds become fast and predictable. So, this image works, but it isn't very efficient. And the reason has everything to do with how Docker builds images. Each instruction in a Dockerfile becomes a layer, like steps in a timeline. Docker builds them from top to bottom, and it only rebuilds a layer when it needs to. Most instructions trigger rebuild when you change the instruction itself, but copy is different. It also reacts to file changes in your project, even tiny ones. And because it sits so early in the Dockerfile, a small change in your code breaks the cache for every layer that comes after it. That's why your builds feel slow. Docker cache is simple. If an instruction hasn't changed and its inputs haven't changed, Docker reuses a layer. If something did change, that layer and everything after it must rebuild. And just to be clear, the cache only kicks in on the second build. The very first build is always a slow one because Docker has nothing to reuse yet. With our current Dockerfile, this line basically guarantees cache misses. Because any change anywhere, a log file, a config tweak, a frontend file, forces Docker to rebuild everything. So the first fix is simple. Shrink what Docker sees. A Docker ignore file lets you filter out everything that shouldn't be part of the build. Node modules, build artifacts, logs, they don't belong in your image. And they definitely shouldn't bust your cache. Just this tiny file already speeds things up, because Docker handles fewer files and fewer irrelevant changes. The next fix is even more important. We want to place the unstable parts, your changing source code, lower in the Dockerfile, and put stable parts, like package.json, higher, so Docker can reuse those expensive dependency layers. So instead of copying everything at once, we copy only the package files first and install dependencies. Docker will rebuild this step only when your dependencies change, not every time you edit a file. Let's compare. Here's the old version. Change one frontend file and the whole image rebuilds. And here's the improved version. Same file change, but now Docker hits a cache for almost everything. Much better, faster, predictable, and clean. But even with caching, we still have one problem. The backend and frontend rebuild more often than they should, because they share same layers. The real solution is to split the build into stages. That's what multi-stage builds are all about. Clean boundaries and minimal rebuilds. Think of each stage as a clean temporary workspace, almost like building separate images inside one Dockerfile. You build what you need, throw away what you don't, and keep only the clean, ready-to-run output. First stage, the backend. We install dependencies, build the app, and that's it. This stage holds the full build environment, but will never ship it. Second stage, the frontend. Same idea, install, build, done. Again, none of this ends up in the final image. We only keep the compiled files. The final stage is the only one that ships. Here we pull in the compiled backend and frontend, install only production dependencies, and set up the runtime. Everything else, like development libraries and source code, never makes it into this image. Let's build this version. The first build takes the same amount of time or maybe even slightly longer. That's normal. No cache yet. Now let's change one small thing in the frontend, just an HTML tweak, and rebuild. And this time it's way faster. Only the frontend stage and the final copy step rebuild. Everything else comes from cache. And there is one more big improvement. The final image is much smaller now. In the basic version, we were shipping everything. Build tools, dev dependencies, source code, files we never needed at runtime. With multi-stage builds, the final image only contains the compiled backend, the static frontend assets, and the production dependencies. Same app, but the multi-stage version drops all the unnecessary weight. Smaller images are faster to pull in CI, quicker to deploy, and easier to cache across your environments. So it's not just faster to rebuild, it's lighter and cleaner to ship. And now you've got a proper production-ready Docker image, fast to rebuild, smaller to ship, and predictable in CI. And more importantly, you actually understand why it works. You are not just copying Docker files anymore, you can reason about them. If you want to see how Docker fits into the bigger DevOps picture, my free starter map is linked in the description below. It's a simple guide that shows the next skills to focus on: Linux, Git, Docker, pipelines, automation, all connected. What's one Docker build issue you run into? And how did you fix it? Drop it in the comments, I would love to hear your stories. Subscribe if you haven't already, and let's keep learning DevOps together, one small confident skill at a time. I'm Natalia, and I'll see you in the next one.